Okay, back to the 5.6 notes, rational functions. This is page 3. We are now going to talk about horizontal asymptotes. Remember, horizontal asymptotes are going to go this way, left to right. For our function, one thing I want to make clear here, we've got p of x over q of x, and we're going to call m the degree of p, and n is the degree of q. And quick reminder that degree means highest power. Highest power in the polynomial. So there are 3 things that can happen. We can have the degree of the numerator less than the degree of the denominator. We can have the degree of the numerator equal to the degree of the denominator. And we can have the degree of the numerator less than the degree of the denominator. Okay? If the degree of the numerator is less than the degree of the denominator, then you have a horizontal asymptote at y equals 0, which is the x-axis. If the degree of the numerator equals the degree of the denominator, your horizontal asymptote is at y equals the ratio of the leading coefficients. Maybe I shouldn't use A for both. Let's use B for the bottom. Not that it really matters, but they're both just variables. B sub n. And nobody corrected me here. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. We will have a slant or oblique asymptote. And I will go through an example on the last page here, but I don't believe that the homework asks you to find one of those. Yeah. Okay, so let's look at crappy example numbering here. I'm not sure what's going on. Sorry about that. So, example 1. The degree of the numerator is 4 and the degree of the denominator is 4. Highest power, highest power. So my horizontal asymptote is at y equals 6 over 9. It's the ratio of those leading coefficients, which of course we want to reduce if we can. Not going to worry about it. Example 2, I have got a degree in the numerator of 3, a degree in the denominator of 1, x to the first. So we have no horizontal asymptote. And then for example 3 here, I have got degree of my numerator is 1, degree of the denominator is 2. Degree of the numerator is less than the degree of the denominator. So my horizontal asymptote is that x-axis, y equals 0. Okay. Now let's take a look at example 2, listed over here, h of x equals 2x over x plus 3, and use everything we have to graph this. So I always start with the denominator. Let's see if we can match up colors. X plus 3 cannot be 0, so x cannot be negative 3, which means I have a vertical asymptote at x equals negative 3. So there is my vertical asymptote. My graph is not going to cross. I have degree in the numerator is 1, because I got a 2x. Degree in the denominator is 1. So I know my horizontal asymptote is at y equals, I got 2x, so 2 over 1x, y equals 2. So there's that part. I also know that my zeros or x-intercept is going to be what makes the numerator 0. So when x is 0, y is 0. Which also takes a little bit of the fun out. I would have found the y-intercept next by plugging in x equals 0. But I already know when I plug in x equals 0, my y is going to be 0. Now, here's the thing. I could plug in numbers to see if I can figure out what's going on. I know that as I go up, I can't go up to the left because that's going to hit an asymptote. Also know that as I go down, it's not going to curve in this way. That also hits an asymptote. So the only way my graph can look down here in this corner is up and approaching the asymptote this way, and down and approaching the asymptote this way. Okay. Because I don't have an x squared, it's highly unlikely that things are going to be different. I am going to take a look at plugging in negative 4 and see what happens to the left of that vertical asymptote. So I got h of negative 4 is 2 times negative 4 over negative 4 plus 3. Negative 8 over negative 1, which gives me 8. So I got the point negative 4, positive 8. Negative 4, positive 8, way up here. And I know that it's going to come down and approach this asymptote out here somewhere.